Okie doke. So in geometry, you guys learned about two different types of special triangles, right? We had 30, 60, 90, we had a 45, 45, 90 triangle. So if I gave you one side length of a 30, 60, 90 or a 45, 45, 90 triangle, you should be able to figure out the other two, yes? Technically, they're just special right triangles, like, because it's using Pythagorean theorem, right? But if I only gave you one side length, you should be able to figure out the other two no matter what. So you've got three pictures here, 45, 45, 90 triangles with different side lengths. I want you to try and remember, if you don't remember, what is the relationship between the side lengths, so like these side lengths, and the hypotenuse. How are they all related in a 45, 45, 90 triangle? Don't shout it out, but write it down / talk to your neighbor about it, and then we'll talk about it. All right, do we remember what the relationship is between the side lengths, like the ones that I highlighted there that are in black up there? Like, how are these 4 square root of 2 and 4 square root of 2 related? Or 3 square root of 2 and 3 square root of 2? Or square root of 2 over 2, square root of 2 over 2? Yeah, they're the same, right? In terms of like an actual kind of, oops, that's not what I wanted. Explain everything just is not the greatest. I want it to be the other way. How do I make it? There we go. Okay, that's what I wanted. Okay. Oh no. Sorry guys, technical difficulties. There we go. If we call these x for my 45, 45, 90 triangle, then my hypotenuse I can find by timesing that by what? Not 2, but the square root of 2. This is x times the square root of 2. Now if I go and look at that, if I did 4 square root of 2 times the square root of 2, don't I get 8? Yeah. If I take 3 square root of 2 times the square root of 2, don't I get 6? And lastly, if I take the square root of 2 divided by 2 times the square root of 2, I get 2 over 2, which is 1, right? Which is how I got that hypotenuse, okay? So the relationship between the sides and the hypotenuse, we know, is going to be multiplied by the square root of 2. So the legs are the same in a 45, 45, 90 triangle. And the hypotenuse, I'm just going to abbreviate with HYP, is the leg times the square root of 2. Now, if I wanted to go backwards, if I was given that the hypotenuse, let's say, is 10 square root of 2, how would I find my leg? Divide by the square root of 2, right? So my leg would be 10 in that case. Cool. Okay, now we're going to start introducing sine and cosine of these kind of special right triangles. So if I wanted to find, I'm going to do this first triangle here in red. If I wanted to find the sine of 45, okay? Sine of 45 degrees, I can choose either one. I can choose this one or the bottom one. Sine is opposite over hypotenuse, right? So sine would be 4 square root of 2 divided by 8. Now if I simplify that, what do I end up with? Square root of 2 over 2, right? Because 4 over 8 simplifies to give me 2. So I get square root of 2 over 2. Okay. What if I did cosine of 45? Cosine is adjacent over hypotenuse. If you forgot these things, remember, SOHCAHTOA will help you out. Oops. And I heard someone say, yes, isn't it the same thing? It is, because the adjacent is also 4 square root of 2 divided by 8, which is also going to give me the square root of 2 over 2. So cosine and sine, in terms of a 45, 45, 90 triangle for this, are the same. Is that the case with every 45, 45, 90 triangle? Let's find out. Okay, let's do the second one. I'm going to set up my sine and my cosine ratio. Sine of 45 from either angle of 45 degrees, doesn't matter. Opposite would be 3 square root of 2. My hypotenuse is 6. So I have 3 square root of 2 divided by 6, which gives me what simplified? Square root of 2 over 2. Again. Okay. Cosine 45. What's going to happen? Same thing, because the side length that's adjacent is also 3 square root of 2 over 2. So I also end up with the square root of 2 over 2. Okay, go ahead and do the last one for me. Set up your sine and cosine ratios for that last triangle. Okay, if I set up my ratios again, what'd you guys find out for sine and cosine? It's the same thing, and you also end up with the square root of 2 over 2. Technically, it's divided by 1, so I don't need to really do any simplifying, but I just get my answer of square root of 2 over 2. So they are both the same thing. Okay. Question C is just kind of asking us, if we had to look at all three of these triangles again, which one was the one that gave us the answer the quickest? Like, which one was the most obvious obvious to figure out? The last one, why?
Because we didn't have to do anything.
Yeah, we didn't have to simplify it, right? Because we're just dividing by 1. So my last triangle was the easiest because my hypotenuse was 1. And dividing by 1 is not going to change anything. Okay, so that was just a little bit easier for us to visualize. Okay, we also talked about 30, 60, 90 triangles in geometry. Okay, 30, 60, 90 triangles have a special relationship between the short side, the long side, and the hypotenuse. Okay, when I say the long side, I mean like this side length right here. That's a leg. I know technically the hypotenuse is the longest side, right? But my 2 legs, how are those related to my hypotenuse? Talk about it with your neighbor for a minute and then answer out that question A. Okay, if I were to draw my generic triangle, 30, 60, 90. Okay. Oh, man. Real technical difficulties here. So this is 60, 30 degrees, 90 degrees. If we called my short leg x, my hypotenuse is related to that how? 2 times x. Okay? And then my long side, like this was 4, so my long side is 4 square root of 3. So what would my long side be in this generic kind of equation there? Or that triangle? Yeah, x times the square root of 3. Okay? The way that I remember square root of 3 versus square root of 2 is that square root of 3 happens when I have a 30-degree angle. Okay, the threes go together. So our relationship between the short leg and the hypotenuse is that the hypotenuse is 2 times the short leg. And that was the case for every single triangle up here, right? This formula works for every single triangle that is up there for 30, 60, 90. And the nice part about the special right triangle is if I even just gave you that this side length right here was 10 and it was a 30, 60, 90 triangle, I could figure out those other 2 side lengths, right? Yeah. But if we were trying to do Pythagorean theorem, I need at least how many side lengths to do that? 2, okay? So that's why the special right triangle here is so powerful for what we're doing, okay? Okay, we're going to choose one of these triangles up above, and we're going to choose the smartest triangle, just like we did up above. The very last one was the easiest because my hypotenuse is 1. Which one should we choose for finding my sine and cosine? The middle one, okay? If I choose the middle one, my hypotenuse is 1, and it's going to make those ratios a little easier, okay? So I want to find the sine and cosine of 30 degrees. So sine of 30 degrees is equal to my opposite side over my hypotenuse. So I'd have 1/2 divided by 1 is just 1/2. Okay, if I did cosine of 30 degrees, cosine would be what first? Square root of 3 over 2, my adjacent side, divided by my hypotenuse. So that's just the square root of 3 over 2. So notice here, like this triangle that we were just given, the sine of this angle was just a side length. Okay? The cosine of this angle is just a side length. Okay? Specifically the horizontal side length and the vertical side length. Okay? Now I'll give you guys a minute. Try the same thing with the same triangle, but do sine of 60 and cosine of 60, and then see what you notice between B and C. Okay? Okay, so I've got my sine of 60 and cosine of 60 up there, which should hopefully be what you got. How do these relate with what we just found in B? They flipped, right? So specifically, we could write an expression or an equation actually that says that sine of 30 degrees is the same thing as cosine of 60 degrees. And cosine of 30 degrees is the same as sine of 60 degrees. Okay, while the unit circle does seem kind of scary, there are really just a ton of different patterns that are happening within the circle itself. Okay, so when you look at it at one glance, you're like, holy cow, I'm not ever going to be able to know anything on that. But once you kind of see the patterns, and you kind of just have to see them and figure it out on your own, I'm going to show you the patterns, but you've got to kind of figure out how it works for you. It's going to get easier. Okay? All right, moving on to the next page. These three circles here are kind of like three separate unit circles, and we're like zooming in on three different types of specific triangles, okay? They are the 45, 45, 90 triangles, and they are the 30, 60, 90 triangles, okay? If you look at the first one here, see how my like long side of that triangle is like on the x-axis, right? Whereas the last one, my long side is this like y value of that triangle, that height, okay? Where my short side is on the x-axis. So it's like we flipped where the triangle went, right? The 45 ones are nice because, I mean, it's 45 degrees, so it's going to be halfway in between all of these quadrants all the way around, okay? So let's look at this first one here, okay? We're going to use this idea of 30, 60, 90 triangles to help us figure out all of these coordinates around the unit circle. So if we were given a 30, 60, 90 triangle, remember what that looks like here. Got to figure out how to use this. Okay. Whoa. Okay, this was my 30 degrees, 60 degrees, 90 degrees. We called this x, we called this 2x, and we called this x times the square root of 3. In the unit circle, okay, all of my radius are going to be 1 every single time. So if this is technically 1, what would my x or my short side be? If I have this is equal to 1, that's equal to 2x, what would x equal if I solve this? 1/2, right? So this would be 1/2. And then this side length, this long side, would technically be 1/2 times the square root of 3, right? Or the square root of 3 over 2, right? These numbers should look familiar. Didn't we just find those on the previous page? Yeah. For cosine and sine? Exactly, we did. Okay. So letter A asks us, what is the value of theta in radians? So this theta right here is 30 degrees. So 30 degrees changed to radians, we multiply that by pi over 180, right? So that simplifies to give me what? Pi over 6. Okay, now we need to find the x and the y coordinate. That's where like... Okay, so now the next thing is asking us to find the x and y coordinate of the points that are shown, okay? Let's talk really quick just about generic points in quadrants. If I was in the first quadrant, my x and y axis would both be positive, yes? What changes in my second quadrant? X is negative, right? So it'd be negative, positive. In my third quadrant, I should have negative, negative. And in my fourth quadrant, I would have a positive x value and a negative y value. We good with that? Okay. So now I want to find the x and the y coordinate. So what I want to know is what is this length here of this long side of this triangle? Because won't that give me my x value if I find the long side? And isn't my short side of the triangle just my y value? Yeah, don't I know those two things from the triangle we just found here? Yeah, we know that this long side is the square root of 3 over 2, and this short side is 1/2. So my coordinate would just be the square root of 3 over 2, comma, 1/2. Another thing to note, if you look back at the previous page and look at cosine of 30, if you look back, was the square root of 3 over 2. So cosine is technically our x value, and that's where it gets a little kind of tricky for us to realize this. Cosine, I'm going to write this up top. Cosine is our x values of our triangles, and sine is going to be my y values. Okay, makes sense in terms of the alphabet. C comes before S, right? So x comma y, cosine comma sine. Okay, so now I gotta label the rest of these points around the circle. So I've got square root of 3 over 2, comma 1/2. The only thing that's gonna change in my second quadrant is it's gonna make it a negative. Square root of 3 over 2, positive 1/2. Third quadrant, they're both negative. Fourth quadrant, it will be a positive and then a negative. Okay, so right there we just figured out 4 points around the unit circle. Okay. Now, how the unit circle comes into play, you're going to be asked questions like evaluate the sine of 7 pi over 6. Okay, now let's think about number sense here. 7 pi over 6. We've got 4 lines here, okay? 7 pi over 6 is one of those 4 lines. Which one would it be? What quadrant would 7 pi over 6 be in? The third quadrant, right? Because this is just a little bit more than 6 pi over 6, which is pi, right? So it's a little bit more than that, so I know that that's going to be that angle here, okay? So from this angle here, I'm going to kind of color code this here as red. That angle, it's asking us to evaluate the sine, okay? Sine means I want to know what the y value is at that point, 7 pi over 6. Well, what's my y value at that point? Negative 1/2, right? So the answer to sine of 7 pi over 6 is negative 1/2. And I could also technically find that by doing my trig ratio. Sine is opposite over hypotenuse, right? Well, I know that this side length is my opposite side, and that distance is negative 1/2. My hypotenuse is 1. So sine of 7 pi over 6 would equal negative 1/2 divided by 1, which is just negative 1/2. Okay, so you can set up your ratio like that, or you can think, what is the y value at that point? Okay. Okay, your cosine of 11 pi divided by 6. Which quadrant would 11 pi divided by 6 be in? Fourth, yeah. 11 pi over 6 is really close to 12 pi over 6, which would be 2 pi, right? So that's that point right there, that angle. If I want to know my cosine, I can set up my trig function, or cosine is going to be your x value. Okay, so my x value of this point is going to be square root of 3 over 2. You're going to be able to evaluate these things by hand without using a calculator, okay? Okay, since we're in the mode of 30, 60, 90 triangles, let's flip down to the bottom circle, okay? Because this is also a 30, 60, 90 triangle. However, instead of my 30 degrees being down here where theta is, that's actually going to be my 60 degrees. So I'm going to draw my triangle again, where this is my 60 and this is 30 up top. Okay, I know my hypotenuse is 1, my radius is 1 all the time, so my short side across from 30 is going to be what? If my hypotenuse of a 30, 60, 90 is 1, my one side would be half of that, right?
Oh.
Yeah, so 1/2 would be the answer for that one. And then what's my long side going to be if my hypotenuse is 1? square root of 3 over 2. Because I take my short leg and I times it by the square root of 2. Okay, are we okay with all those values? Okay, so it asks us what kind of triangle we've had, or sorry, what type, I can't talk, what type of triangle we have. We have a 30, 60, 90 triangle. Theta here is pi over 3. What does pi over 3 equal in terms of degrees? If the other one was 30 degrees, this one would be 60 degrees. Okay, that's what we just wrote down there. So these are 30, 60, 90 triangles. Okay, so now I need to find what the x and y coordinates of these points are again. So my short side, that's going to give me my x value, right? So my short side here is 1/2. So I've got 1/2, and then my y value is going to be square root of 3 over 2. Okay, I'm going to give you a minute, fill out the rest of those points, changing your positive and negative values where they're supposed to be changed. And then once you get done with that, try letter C out. Try evaluating the cosine of 2 pi over 3. I'm going to throw up the coordinates up here, double check that you have the same answers as me and that I didn't make a mistake. Please and thank you. We all agree with those 4? Sweet. And then if I was evaluating the cosine of 2 pi over 3, I always kind of use pi as my reference point. Is 2 pi over 3 smaller or bigger than pi? Is 2 pi over 3 smaller or bigger than pi? Smaller than pi, right? So if it's smaller than pi, these are all going to be in terms of pi over 3. So this right here would be my actual 2 pi over 3 coordinate, okay, or angle. So if I'm evaluating the cosine of this angle, cosine is going to be my x value. So my answer would be -1/2. Or you can think about rewriting it in terms of your ratio. Cosine is adjacent, which is this side length, -1/2, divided by my hypotenuse is 1. That gives me the same thing, okay? You can either set up your ratio, or you can know if it's an x value, it's an x value if you're trying to find cosine, and it's a y value if you're trying to find sine, okay? All right, now if I want to evaluate tangent, okay? Tangent is opposite over adjacent, right? And I'm using that same angle. So tangent of 2 pi divided by 3 from this angle would be the opposite side length. So this side length here, which is the square root of 3 over 2, divided by my adjacent side length, which is -1/2. Okay? Or technically this is my y value divided by my x value. And if I simplify this fraction, the square root of 3 over 2, and then I copy dot flip, so multiply it by -2 over 1, I end up with my tangent of 2 pi over 3 being the negative square root of 3. Let's move to the 45, 45, 90 triangles. Okay, remember your 45, 45, 90 triangle formula is this side length of x, this side length of x, and my hypotenuse would be what? X times the square root of 2. And this is a 45, 45, 90. Okay? Now, specifically in our unit circle is always going to have a radius of 1. So this is going to be actually 1. And then how am I going to find my short leg and both of my sides of my triangle? Yeah, divided by the square root of 2, which just gives me the square root of 2 over 2 and the square root of 2 over 2. So this one's nice because it's just going to be the same thing for all your coordinates, except you're just going to have to be careful with your positives and negatives, okay? So my first coordinate here would be square root of 2 over 2, square root of 2 over 2. And they're all going to be the same except for they're going to have different signs in different spots, right? This is going to be a negative square root of 2 over 2 and a positive. And then these will both be negative. And then I'll have a positive and a negative. Okay, so can we already see a lot of patterns going on here in those 4 triangles for each set of these circles that we have? So if I wanted to find the sine of 3 pi over 4, think about that in terms of pi. Is that going to be bigger or smaller than pi? 3 pi over 4. Smaller than pi, right? 3 divided by 4 is like 0.75 pi. So I know that this 3 pi over 4 is this angle right there. So if I wanted to evaluate sine of that angle, sine is going to be your opposite side length over my hypotenuse, or it is your y value of this point. So my y value of this coordinate is what? Square root of 2 over 2. Okay. Tangent of 7 pi over 4. Tangent of 7 pi over 4 means that it's going to be larger than pi for sure. And it's going to be where? In the 3rd quadrant or the 4th quadrant for 7 pi over 4? The 4th quadrant, right? Because it's almost 2 pi. So this right here is the point that we're looking at for tangent of 7 pi over 4. Remember, tangent is the same thing as sine over cosine. Okay, so we could find my y value over my x value, or I can use tangent to set up my ratio. So this would be negative square root of 2 divided by 2, all divided by my x value of square root of 2 divided by 2. Which that looks pretty gross. We can simplify that. What is this going to equal? Negative 1. The same thing on top and the bottom. Simplifies to give you 1. So negative 1 would be your answer. We're going to skip this page. Okay. And then I want you guys to go back to your other notes in your last, the last thing we're going to do today is fill out this unit circle on your note sheet so that you have one filled out unit circle, and we're going to kind of build it together. So I'll give you guys a second to grab that out. We're going to start out by filling out the angles, okay? From 0 to 360 degrees. We already did that on that little card sort that you guys just did. But I am going to go about this in kind of a strategic way. I'm going to go count all the 45 degrees first. Okay, so I'm going to start with 0 degrees. And then my 45 degrees is going to be halfway in between that first quadrant here. Okay, so this is going to be 45, followed by 90 degrees. If I add 45 to that, I'll end up with 135 degrees. Add 45 again, I end up with 180. Okay, add 45 again. A few more times. I'm just going to kind of separate these out. These are all my 45 degree angles here. Okay, do we agree with all those 45 degree angles? Adding 45. Okay. Okay, now I'm going to go back and I'm going to add 30 degrees at a time. Okay, so when I add 30 degrees, we're going to have this angle here, which will be just 30. Then if I add 30 degrees again, what am I going to be at? 60. If I add 30 degrees again, we already have that one, 90 degrees. 30 degrees again, I'm going to be at 120. 30 degrees again, 150. 30 degrees again, we're at 180. 30 degrees the rest of the way around. fill in those blanks here. So 210, 240, we're at 270, and then 300, 330, and that's 360 degrees. Okay, so that's just all my degrees. Now I want to go back and we're going to do our radians. Okay, starting with 30 degrees, we're going to start with all of our 30-degree increments. Okay, because if I add 30 degrees every single time, technically what am I adding in terms of radians? What is 30 degrees as a radian? If we take 30 and times that by pi over 180, what's that give me? Pi over 6. So this right here is pi divided by 6. Okay, if I add pi over 6 to that, wouldn't I be at 2 pi over 6? But 2 pi over 6 simplifies to give me what? Pi over 3. Okay, so you're going to be asked like pi over 3 stuff. You're not going to be asked 2 pi over 6 questions. Okay, so you need to know where is pi over 3 at in my unit circle. It's actually bigger than my pi over 6. Okay, if I add pi over 6 again, that's going to get me to 90 degrees, which would actually be 3 pi over 6, which simplifies to give me what? Pi over 2. Add 30 degrees again. I end up with, or sorry, not 30 degrees, but add pi over 6 again, and I end up with 4 pi divided by 6, which is the same thing as 2 pi over 3. Add pi over 6 again. I'm at 5 pi over 6. Add pi over 6 again. I have 6 pi over 6, which is equal to what? Just pi. Okay, entering quadrant 3 here. Add pi over 6 again. I end up at 7 pi over 6. Add pi over 6 again. 8 pi over 6, which is the same thing as 4 pi divided by 3. Add pi over 6 again. I get 9 pi over 6, which is the same thing as 3 pi over 2. Next one will give me 10 pi over 6, which simplifies to give me 5 pi over 3. Followed by 11 pi over 6. And then 360 degrees in terms of radians would be what? 2 pi. Okay, and actually 0 degrees would also be 0 radians up top. Okay, so that was increments of 30 degrees or pi over 6 all the way around. So now we need to go back and do increments of 45 degrees in terms of radians. What is 45 degrees in terms of radians? If I did 45 times pi over 180, gives me pi over 4. Okay, so this one's going to be pi over 4. Then 90 degrees is technically 2 pi over 4, which that's the same as pi over 2, right? My second quadrant here, I would have 3 pi over 4. Followed by 4 pi over 4, which is pi. Followed by 6 pi over 4. Which is the same thing as, wait, nope, I missed one. Sorry, guys. This is supposed to be 5 pi over 4, because we just had 4 pi over 4, right? This is 5 pi over 4. That doesn't simplify. The next one at 270 degrees would be 6 pi over 4, which is the same thing as 3 pi over 2. Add pi over 4 to 6 pi over 4, and that gives me 7 pi over 4. And then I end back up at 360, which is 8 pi over 4, which is 2 pi. Okay? So those are all my degrees and radians, and that is what I would really like you guys to kind of practice between now and Thursday. We're going to start with the 4 most easiest points on the unit circle. Okay? The radius is 1. Without having to do any sort of trig and thinking about right triangles, I want us to choose what these 4 points are. If my radius is 1, how would I label those 4 points? What's the first one going to be?
0, 1.
Opposite. My radius is 1, so this is 1, comma, 0. Okay. My 90-degree coordinate would be?
-1.
Not -1.
Just 1, 0.
1, 0 is this one right here. So the top, do I go anywhere? Left and right? No, I just go straight up, right? So this would technically be my x value is 0, my y value is 1. Okay, the left coordinate there, it's straight over -1. So this would be -1, comma 0. And then straight down on that y-axis would be 0, comma -1. Okay? Okay, now I'm going to draw my 30, 60, 90 triangle in here. Whoa, that's not what I wanted. Okay, so that coordinate right there, if we kind of look back on the previous notes that we just did, that was our first circle, okay? And that coordinate on that circle was the point square root of 3 divided by 2, comma 1/2. Okay, now I'm going to go to that point exactly on the other side. That point on the exact other side would be this point right here. If I were to draw that triangle and flip it over the x-axis, then this point would be negative square root of 3 over 2, comma 1/2. Flip that point down over the x-axis, I would have this point right here at 210 degrees. And your coordinate would be negative square root of 3 over 2, negative 1/2. Followed by our last one over there would be positive square root of 3 over 2 and negative 1/2. Okay, that was my first 30, 60, 90 triangle that we did on that kind of discovery stuff. Next thing that we did on that discovery was the 45, 45, 90 triangles. Okay, so these 45, 45, 90 triangles right here had the coordinates of square root of 2 over 2. Okay, so my coordinates are going to be square root of 2 over 2, square root of 2 over 2. And then it's just going to change positive and negative signs all the way around. So in the second quadrant, I'm going to have the negative square root of 2 over 2, positive square root of 2 over 2. In the third quadrant, they're both going to be negative. So I'm going to have negative square root of 2 over 2 and negative square root of 2 over 2. And then my fourth quadrant, I'm going to have a positive followed by a negative. Then my last triangle we talked about was the 30, 60, 90 triangle, but it was just flipped. So it's going to be this triangle here that I'm looking at. That's my 30, 60, 90 triangle. And those coordinates are going to be the opposite of our other 30, 60, 90 triangle. So instead of square root of 3 over 2, comma 1/2, it's going to be 1/2, comma square root of 3 over 2. Second quadrant, my first point is negative. Second point stays positive. Third quadrant, they will both be negative. And then last quadrant, positive and negative. So that whole thing right there is the unit circle. Okay, that took us quite a bit of time to write it all out on here, and it's going to take us quite a bit of time to kind of get comfortable with what this stuff means and how do we use this triangle to answer questions. Okay, what I would like you guys to do between now and next class is to be able, especially to tell me the difference between the angle and the degree. Like if I asked you pi over 6, like where does that line like land on your unit circle, you should be able to like tell me it's going to be in the second quadrant. Okay, and then you should be able to kind of quickly figure out what is that going to be in degrees. Okay, I want you to be able to do the angles in degree and radians, and then we'll work on the coordinates. Okay, but do we see how if we just knew this first quadrant here, we know all the rest of it? Yeah, okay. So if I can figure out the first quadrant, we're going to figure out the rest of it pretty easily, but we need to know where that angle measure is, okay? I will show you some tricks next class. If you look any of this stuff up on Google, there are a bunch of different tricks for unit circle stuff, so I'll kind of show you the ones that I like, but you don't have any homework other than to try out that Desmos maybe 1 or 2 times before next class, okay? Sound good?